Hey everyone, welcome back. This is lesson 8.3, Adding and Subtracting Rational Expressions, Part 1. Your objectives for today: by the end of this lesson, you'll be able to add and subtract rational expressions. You'll also be able to simplify complex fractions. Your vocabulary for today is complex fraction. All right, for a quick warm-up, I want to review you over adding and subtracting fractions. Remember, before we can add, we have to have a common denominator. So I noticed that 15 is made up of 5 times 3, and this one is 5. So in order for them to be common, this one needs to have a 3 multiplied by it. And if I multiply the bottom times 3, I have to multiply the top times 3. So in the end, I have 6 over 15 plus 7 over 15 for a grand total of 13 over 15. Again, down here, I see that 12 is made up of 4 times 3, 8 is 4 times 2. So in order for them to be common, I'm going to need to multiply a 2 on this side and a 3 on this side, giving me 24. Now, if I multiply by 2, this expression by 2 on the denominator, I also need to multiply 2 in the numerator. And over here, if I multiply by 3 in the denominator, I also have to multiply 3 in the numerator. So in the end, I get 22 over 24 minus 9 over 24, and that gives me a grand total of 13 over 24. All right, to simplify, remember, I can divide both the numerator and denominator by 4, and that gives me 1 and 3. And then for our x's, divide both of them by x over 3. That goes away. That becomes 6. So I end up with 1/3 and x to the 6th. So that should be a good, just a review for you. Now, to make sure that it's undefined, we could say, okay, 12x to the 3rd. If that equals 0, then that's undefined. And so when x equals 0, it would be undefined. So x can't be equal to 0. Again, over here, before we can simplify this, we need to simplify x squared minus 1. I recognize that is the difference of two perfect squares, x plus 1, x minus 1. And here I can see that my x minus 1s can cancel out. That leaves me with just 1 over x plus 1. Now remember, define when it's undefined, I have to look at both of these parts. So when x equals -1 or x equals +1, my expression would be undefined. So here's my answer. Adding and subtracting rational expressions is similar to adding and subtracting fractions. To add or subtract rational expressions with like denominators, all you have to do is add or subtract the numerators and use the same denominator. So 1/5 plus 3/5 equals 4/5. 6/7 minus 4/7 equals 2/7. So that's pretty simple. So let's do some a little more complicated problems. All right, so our first example says to add or subtract, and then we're going to identify any x values for which the expression is undefined. So fortunately, we have fractions, but they both have common denominators, so we really don't have to do anything on this one. We just have to add the numerators together, and when we put our like terms together and add it up, we end up that 2x minus 5 over x plus 4. Now, notice that the expression is undefined at x equals minus 4, because this value makes x plus 4 equal to 0. And when there's a 0 in our denominator, our expression is undefined. All right, that one's pretty simple. All right, this example is asking us to subtract this time. So first thing we want to do is take a look at our denominators. Are they the same? Yes, we do have a common denominator. So all we have to do is subtract our numerators. But I want you to be really, really careful when you subtract, because you have to subtract this entire piece of 6x plus 1. So we need to be sure to distribute our negative to both of those pieces. So we're going to distribute our negative sign, and now that I've done that, I can see what my actual problem looks like. 3x minus 4 minus 6x minus 1. All right, so then once we combine all of our like terms, we get 3x minus 5 over x squared plus 1. And so now all we have to do is check. And notice that it says there's no real value for x, for which x squared plus 1 equals 0. So this expression is always defined. So I want to just check and make sure you understand. If I have x squared plus 1 equals 0, to solve for that, minus 1 on both sides, I would have x squared equals negative 1. To solve for x, we would square root both sides, ending up with me having x equals square root of negative 1, which we remember is an imaginary number. And this is telling us there's no real value, but this would be an imaginary value. That's why the expression is always defined, because there's no real value for which x squared plus 1 equals 0. All right, here's one for you to try on your own. Just turn your video off and give it a try. All right, I don't think you should have had very much problem with that because we have a common denominator right here. So all we have to do is add our numerator. And when we do that, you combine your terms. You get 9x plus 4 over x squared plus 3. And let's talk about when the expression is undefined, okay? So here we had to say x squared minus 3 equals 0. So x squared equals positive 3. We can do that. We square each one. So when x is equal to square root of 3, then our expression down here would be 0. And we can't have a 0 in the denominator. Otherwise, it's undefined. So the expression is undefined at x equals plus or minus square root of 3. A little bit of a tricky one there for you. All right, here's another one for you to try on your own. Go ahead and turn your video off and give it a try. Just be careful to notice that it's a minus, so you have to distribute that negative to all the terms there. Okay, so I hope you were able to get that pretty easy. The first thing we check is, does it have a common denominator? Yes, it does. So next we just have to subtract our numerators, but before we can do that, we have to be sure to distribute our negative sign to everything. And once I've done that, then I can go ahead and combine the like terms, and you end up with x squared plus 3x minus 3 over 3x minus 1. Now, don't forget you have to identify when the values, x values for which the expression is undefined. So we're going to take our 3x minus 1 equals 0, so add 1 to both sides. We have 3x equals 1. Divide both sides by 3, so x equals 1 over 3. All right, so that is when our expression is undefined. So the expression is undefined at x equals 1 over 3. To add or subtract rational expressions with unlike denominators, first find the least common denominator. The least common denominator is the common multiple of the polynomials in the denominator, just like we did in our warm-up. All right, so to find the least common multiple of polynomials, the first thing you want to do is factor each polynomial completely. All right, and then write any repeated factors as powers. So for example, let's look at x to the third, this expression here, x to the third plus 6x plus 9x. Okay, I can see that there's a common x in all of those. So I'm going to go ahead and pull the x out. And then I end up with x squared plus 6x plus 9. Now I have to factor that. So remember, two numbers that multiply together to get 9, add together to get 6 are 3 and 3. So this is going to be x times x plus 3, x plus 3. All right, and it can be written as like this, 3 times x plus 3 squared. All right, the second thing you want to do is list the different factors. If the polynomials have common factors, use the highest power of each common factor. All right, so let's look at an example of these. The first one says to find the least common multiple for each pair. So we're going to start out with the 4x squared y to the third. And let's break it down into its factors. Its factors are made up of 2 times 2 times x squared times y squared. Now take a look at 6x to the fourth y to the fifth, and we see 6 is made up of 3 times 2 times x to the fourth y to the fifth. So to find the least common multiple of that, we're going to have to take a look at what they have in common. So there's going to be, has to be 2 2's. All right, and this one has 1, so it's got at least 2 in there. I have to have a 3, so there's my 3. Now my x's, I have an x to the fourth and an x squared, so I have to take the highest one, which is x to the fourth. And for my y's, I have a y to the third and a y to the fifth, so I have to take my highest one. So in the end, I'm always taking the highest exponent. So in the end, I have 4 times 3, which is 12. I have x to the 4th and y to the 5th. And so that's how we find our common multiple. All right, so the next one is a little more difficult because it's not written in factored form. So I'm going to have to factor both of these two. So I'm going to say x squared minus 2x minus 3. Two numbers that multiply together to get negative 3, add together to get negative 2 is going to be negative 3 times positive 1. So x minus 3, x plus 1. That's our first one. Now we're going to take a look at x squared minus x minus 6. Two numbers that multiply together to get negative 6, add together to get negative 1. It's going to be negative 3 times a positive 2. So x minus 3, x plus 2. All right, so here are the factors of x squared minus 2x minus 3. And here are the factors of the x squared minus 1x minus 6. Now, notice that I have an x minus 3 and an x minus 3. So when I'm looking for my least common multiple, I just have to list that one time. I have an x plus 1 here, but I don't have one down here, so I'm going to have that in, and then I'm going to have this last piece, x plus 2. So my least common multiple is going to have one of each. All right, so you try one on your own. Turn your video off and give this one a try. Okay, so on this one, let's take a look for our 4 x to the 3rd y 7. 4 is made up of 2 times 2, which is 2 squared. I'll go ahead and write that up there. And our 3 is going to be 3 x to the 5th y to the 4th. So we're going to take our highest of each. So I've got a 2 squared right here. I have a 3. Of my x's, I have an x to the 5th and x to the 3rd. So I'm going to pick my highest. And my y's, I have a y to the 7th and a y to the 4th, so again, I pick my highest. So 4 times 3 is 12, x to the 5th, y to the 7th is my least common multiple. Okay, so for the next one, x squared minus 4, you should have recognized that as the difference of two perfect squares, x plus 2, x minus 2. All right. And so that's pretty easy. And then this one, we have to find two numbers that multiply together to get 6, add together to get 5. That's 3 times 2. So the factors of that are x plus 2 and x plus 3. Now we have to find our least common multiple. So in order to find it, we see I have 1x minus 2 that has to be included. And x plus 2, they both have an x plus 2, so I only need 1. And then I have an x plus 3. And there's your final least common multiple. To add rational expressions with unlike denominators, rewrite both expressions with the least common denominator. This process is similar to adding fractions. All right, so let's just look at a real simple one with fractions here. Notice I have a 6 and a 10 as my denominator. Well, I know that my least common denominator is going to need to be 30 because 6 has a 2 times 3 and my 10 has a 2 times 5. So I'm going to need to have a 2 times a 3 times a 5, which is 30. All right, so 6 has a 2 and a 3, so I'm going to have to multiply 5 to get to 30. So if I multiply the bottom number by 5, I have to do the top number by 5 also. And same with the 3/10. I have a 2 and a 5 already, but I still need that 3 in there. So if I multiply the denominator by 3, I also have to multiply my numerator by 3. So in the end, 2 times 5 is 10, 3 times 3 is 9, 10 plus 9 is 19, and my common denominator is 30. All right, in this problem, we're asked to add, so the first thing we want to do is take a look at our denominators. Are they common? No, they're not. So I need to go ahead and factor out this one over here. Say what two numbers multiply together to get negative 4, add together to get 3. Well, that's 4 and negative 1, so I'm going to say x plus 4 times x minus 1. And notice I already have an x plus 4 over here, so all I have to do to make them common is just go ahead and multiply an x minus 1. But if I do it on the bottom, don't forget you have to do it on the top also. All right, so now I have two expressions that I'm going to add together, and they have a common denominator. So I'm going to have x minus 3 plus, and I'm going to go ahead and distribute that. That's going to be 2x squared minus 2x. So x minus 2x, got to pay attention to that, x squared minus x minus 3 all over my denominator, which is now common, x plus 4 times x minus 1. Now let's take this expression on the top and see if we can factor that. So I have 2x squared minus x minus 3. So I'm going to take my 3 and 2 and multiply them together. I'm going to say two numbers that multiply together to get negative 6, add together to get negative 1. Well, that's negative 3 times negative 2. So my expression on the top is actually going to be x minus 3 times x minus 2. And my expression on the bottom is x plus 4 and x minus 1. Now there's nothing in common that I can cancel out, so that's what my final answer is going to be. Now don't forget the second part of the question says identify any x values for which the expression is undefined. So I'm going to need to say x plus 4 equals 0, so x equals negative 4, and x minus 1 equals 0, so x equals 1. So when x equals negative 4 or x equals 1, our expression is going to be undefined. All right, so the expression is undefined at x equals negative 4 and x equals 1 because these values of x make the factors x plus 4 and x minus 1 equal to 0. All right, so here's another one that you're going to have to try. Again, we need to get a common denominator first, and so this time I'm going to need to factor out this expression. I know x squared minus 4 is the difference of two perfect squares, so that's pretty easy. So that's going to be x plus 2 and x minus 2. So I'm going to look over here. I already have an x plus 2 here, so I just need to multiply this side by an x minus 2. And don't forget, if I multiply it on the bottom, I have to multiply it on the top. All right, so I'm going to distribute my x. That's going to give me x squared minus 2x. And then it says plus a negative 8. Plus a negative 8. All right, and all of that is going to be over x plus 2, x minus 2. All right, got to remember to go ahead and factor out our top expression now and see what we get. So we're going to look for two numbers that multiply together to get negative 8 and add together to get negative 2. Well, I think that's going to be negative 4 times 2. Yep, and so what we have then is x minus 4 times x plus 2 all over our common denominator of x plus 2 and x minus 2. And here I see I have an x plus 2 on the top and on the bottom, so my final answer is going to be x minus 4 over x minus 2. Now, don't forget the second part. Identify the x values for which the expression is undefined. I have to look at these two over here. I can't just look at my answer. So I know x is going to x plus 2 equals 0, so x equals negative 2. And x minus 2 equals 0, so x equals positive 2. So what that tells me is that the expression is undefined at x equals minus 2 and at x equals 2. Because these values of x make the factors x plus 2 and x minus 2 equal to 0. So here's your simplified form where you added it together, and here are when the expression is undefined. Okay, try this one on your own. Turn your video off and give it a try. All right, the first thing you should have noticed is that there are not common denominators here, so we have to factor this out. I can see I can factor a 2 out, leaving me with x minus 1. Down here, I see I can factor a 3 out, leaving me with x minus 1. So in order to get a common denominator, I need to multiply this side by a 2 and this side by a 3. All right, that'll give me 6 times x minus 1 and 6 times x minus 1 on both sides. So if I multiplied 3 on the bottom in the denominator on this expression, I'm going to multiply 3 on the top. And here I multiplied 2 on the bottom, so I'm going to multiply a 2 on the top. So I'm going to go ahead and multiply those on through, and 3 times 3x is 9x, plus 2 times 3 is 6x minus 4. And on the bottom for our denominator, we have 6 times x minus 1. All right, and let's go ahead and add our like terms together. So we have 15x minus 4 all over 6 times x minus 1. All right, so there's our, I can't simplify this anymore. These don't factor out anymore, so my answer is here. But I can't forget to identify any x values for which the expression is undefined. So I'm going to take my denominator, 6 times x minus 1 equals 0. Divide both sides by 6. I have x minus 1 equals 0, so add 1 to both sides. So x equals 1. So when x equals 1, my expression is going to be undefined. Okay. Try one more on your own. Turn your video off and give it a try. Okay, so again on this one we have to check, and we do not have common denominators. So the first thing we need to do is factor this larger one. And so I'm going to say, what two numbers multiply together to get 9, add together to get 6? Well, we know that's 3 and 3, so this is going to be x plus 3 and x plus 3. All right, so I have an x plus 3 over here, but I need to have 2 of them. So I'm going to go ahead and multiply an x plus 3 on this side so that I have a common denominator. And if I multiply x plus 3 in the denominator, I have to multiply it in the numerator. Now all I have to do is distribute that x to everything. So it's going to be x squared plus 3x, and then I already have plus 2x plus 6. So all of that is going to be over x plus 3 times x plus 3. All right, so let's add up our like terms. We have an x squared plus 5x plus 6 all over x plus 3, x plus 3. Now, I'm not finished yet. I have to take a look at this expression here and see if it can be factored anymore. So let's see if we can factor that. So x squared, I'm going to take a look and say, are there two numbers that multiply together to get 6, add together to get 5? And that's an easy one, 3 and 2. So I'm going to rewrite that as x plus 3 and x plus 2 all over our denominator, x plus 3 times x plus 3. And when I do that, I see that I can actually cancel out one of my x plus 3's, so my final answer is right here. Okay, now once you've got that, don't forget we still have to identify any x values for which the expression is undefined. So I have an x plus 3, so x plus 3 equals 0, so subtract 3 from both sides. So when x equals negative 3, our equation is undefined. Okay. And that is the end of this section of the lesson. You can go ahead and turn your video off, take a stretch, and come back in just a few minutes, and we'll get started on part 2.